monitoring.
Yeah. So should I come back here? Where is it? Monitoring.
Yeah. So throughout this, like we have already started to use some of the tools for monitoring, and of course, one big monitoring thing is the output itself. Like the code produces output, you can check the output and see if it's correct. That's one way of monitoring it. But when we talk about monitoring, we often think about, okay, how does the queue perceive things, and what happened when the job ran, like what happened in the queue.
Yeah.
And for that, we have used the Slurm queue to check, like when we have submitted a job, what happens there. Like that's the first thing. When you submit a job, you usually want to check, is it running? Is it queuing? So like, when does it start?
Will it finish today of the 2,000 things I submitted yesterday? When is it done? And so on.
In clusters that don't have the Slurm, like the script that we are using, which is this kind of like helper script, you can use the sq-u user mentioned in the documentation, but we'll also put it into the notes.
I guess
to check the
like here. Yeah.
Yeah.
Okay. What other kinds of monitoring are there?
So the other one, and the major one, is the history. Like we want to see what is the, like what happened, like if the job has finished, what has happened, did it finish correctly, and so forth. And for that, we use the Slurm history. So when we use the Slurm history, we can check, okay, what was the did it complete correctly? Did it like what resources actually used? How long did it take? That sort of stuff, like basic stuff. There's also like if you don't have the Slurm command, you can use this sact-u user. We'll put it into the notes as well, or there's many of these Slurm commands that you can use to monitor. But usually it's a good idea to something like that. Yeah, you can like figure out like what information you want from the job, and you can get a lot of information from the Slurm itself.
Basically, Slurm keeps a huge database of all the parameters of everything that's run, what the commands are, who ran it, where it was run, but then also things like all the resources that were requested and the resources that were actually used. So you can go and submit all your stuff, and then you can return later and then see what finished, what didn't finish, what had errors, how much resources did it use, do I need to adjust any of these things, stuff like that. And that's this. Okay.
And for the, maybe we could jump into the terminal now and view a few of the monitoring outputs. So there's another like this kind of wrapper script in that is usually added with Slurm called the SF. And we have few example job IDs that we can show in the notes, in our own notes. That we could try out.
That you put there. Okay.
Yes.
Yeah, I see. Okay.
Yes. So let's look at few
commands will work on Triton, but not other places, I guess.
Yeah, these are jobs I have run in the past, and let's look at something like that. So once you have a job that has run, you get the job ID, and if you give that job ID to this command SF, it will print out various efficiency information about that. So you will see, for example, here, like, okay, where did it complete? What was the status? Then you see that, okay, how many CPUs did it use? And then it tells how much time it used with those CPUs, like the CPU time. And then it will tell the what is the CPU efficiency. So that just means that how much of those reserved CPUs were utilized. So what is the time?
Is 97% considered good?
Yes. Like 100% would be that it's using all of the time. So 97% is great. And the wall clock time is again like the time that you would see on the wall. So it's like the time in real time. So if you use multiple CPUs, the CPU time can be bigger than the wall time because like you have multiple CPUs running the stuff.
Do we have an example for that?
Yes, next.
Or
But let's look at first the memory utilization. So you can see what was the memory consumption and what was the memory efficiency. So not very good.
Yeah.
And do note that many of these numbers are like they are not necessarily like the true numbers, they're sampled numbers. So what Slurm does is that it samples what the process is doing every now and then. I think it's 30 seconds by default that it samples like what the program is doing. So if your program has like a huge spike of memory consumption or something, it might not be shown in this data. Or if the job like crashes immediately or something, like it might not show correct numbers. So these are like sampled numbers over the whole runtime. So if there's something weird happening that happens quickly, it might not be reflected here, but you can get like the overall big picture. So let's look at one of the jobs that uses multiple CPUs. So the output here is pretty similar. The only difference is that we see that this cores per node is 4. So we're using 4 cores per node. And we notice that the CPU utilized is actually the same, basically. We are doing the same calculation. We're doing the same exact amount of CPU time utilizing, but now it's divided for 4 CPUs, basically. And the CPU efficiency is still very good, but the wall clock has dropped like
it's like
dramatically.
1/4, approximately.
So instead of like taking 41 seconds with one CPU, it's 11 seconds for 4 CPUs. But this also came with a bit more of a increased memory utilization, but at the same time, like we can't really say if that's correct because the sample time is so small, like it's 11 seconds, so it's not that big. And quite recently in Triton, we've added also GPU stats here. So if we take one GPU job, so this was a very simple like a test PyTorch model. So it ran for like 3 minutes, so it's not very big. So you can see here at the bottom, there's now like GPU stats also. So these are again sampled from the on the compute nodes, so you can see what GPU was utilized, what was the GPU utilization, and what was the memory utilization. So the GPU utilization basically here means that how much of the time the GPU was doing calculations. It doesn't say that whether calculations like efficient or whatever. It just means that how much the GPU was just doing calculations. And in this case, like the model is so small that it basically the GPU finishes it immediately when it gets it. So it doesn't utilize the GPU very efficiently. But but in other clusters, there might be other ways of monitoring the GPU usage. A common way is that once you get a job running, you can usually take an SSH connection to the node where the job is running and use this tool called NVIDIA SMI to print out information. There's more information in the documentation about that. So you can monitor you can go to the GPU node and monitor the GPU utilization.
So like while it's running, this is what you can do. There's a good question in the notes. Considering that we have profilers as part of our code, which can be very detailed, how can we benefit from the short summary? So how would you balance the profilers with this kind of reporting?
And that's a good question. Like I think if you know how to use a profiler, or if you know how to profile or get the information from your code itself, it's of course great. Because then you get like much more detailed information. But in a lot of cases, you might be using a program that you don't you don't control what it's doing. And if you want to like add profiling to it, it might like be an extra effort. So with these, you get like numbers from the source. Like you get the numbers based like from the queue system and the hardware itself.
Yeah. So it's like these numbers are free and automatic. So it's like the big picture. And if you see these numbers are low, then you go to your profilers and you can understand why and make it better, or understand that it's as good as it can be. Something like that.
Yeah. So it's the kind of
That's
like,
the basic idea.
Like have you tried turning it on and off again kind of a situation where like you first do the simple things, and then you like if it's still like you first do the you try out the simple things, and then you try the more complicated things usually. So if you want to profile your code, the easiest way is usually just look at these numbers and see like, okay, what are these numbers saying? And then if you want more fine grained information, you use a profiler or something. We can post some good like profiling tools into the notes soonish that can do it for you with minimal hassle. But yeah, like that they are not like one or the other, but this is like something you get for free, like Richard said.
Yeah. Okay, what else? There's an interesting question. Is there a way to have it write this efficiency information to the job output files automatically instead of only being in the database? And that's a good question, I guess. So when it appeared there automatically in the Gutenberg stuff, that's because the code itself was written to do that.
Yeah, I'm not certain. Like me, in principle, yes, probably, but I think like because it's hard to put it into the job script itself, because the stats are not like recorded until the job, unless the job like finishes, like, or if they're not finalized. So it's like you're bootstrapping yourself, basically pulling yourself out with your own bootstraps, and it becomes so quite complicated. But I can imagine that you could do some sort of like a script
like
you can do after the job has run.
Or you can wrap it in a profiler or something that will track this. Like for example, one trick that I sometimes do, user bin time -v, and it has to be the full path because otherwise it's a bash built in. And then if you run something like py.py, that's 2.5 million. So this will run, and it automatically, so this is from time. So time prints out all of this other stuff, which will tell you some basic summary. So the user time in seconds, what percentage of a CPU was used during this time period, and some other interesting technical stats there. So this doesn't tell you the overall efficiency of like of memory efficiency and so on, because time doesn't know how much memory was allocated to the job and so on, but it has stuff.
But yeah, like you can do various I think
if I do it with 2 threads,
it's cores.
It's cores.
Yeah,
let's run it with help.
Yeah, but maybe we should move forward.
Yeah, I guess we should go on. It's nprox.
Yeah.
And here we see it says 190% of a CPU, which means it's using almost 2 CPUs.
But there's plenty of these kind of programs that you can use to do the monitoring.
Yeah.
So, but and we'll note, put into the notes our favorite profilers, and if you have your favorite like tools that you can use to profile, do add them there as well, so that other people can benefit from knowing about them. But basically, this is like usually when you run something in the queue, and if you think that the job is using like 4 CPUs, You think you reserve 4 CPUs, and you think that the job is using 4 CPUs, and then you usually want to look at the SF or whatever to verify that it actually used the 4 CPUs, because like otherwise it's wasted resources, right?
Yeah.
So usually you want to use quickly SF or something to verify that what is the memory usage, what is the time usage, what is the processor usage, in order to set the requirements of your job match more closely to what it actually needs.
Yeah. And if you tried this and you can't figure out what it is, so I'd say always, if you're using resources, always check, see the efficiency. If it doesn't look like what you expect, spend a little time, see if you can understand why. But if not, come talk to us and we can help do that. If everyone would do this, it would make the cluster go much faster because there's a lot less wasted stuff there. Anyway, yeah. Should we go on then?
Yeah, let's go. And next we have a talk. Next we are going to go through some applications. So